Good evening everybody, and once again welcome to the video. In this video I'm gonna be showing you how to power your search stack Elasticsearch from your transactional data lake Apache Hudi. That's right. So again, this is a demo video and there is also a deep dive video. Usually the way I do this is in the demo video I cover the high level topic and followed by a demo, and in the deep dive I essentially explain you every single step. So this is a demo video. So basically, I wrote an article very recently which shows the power of Apache Hudi and how you can leverage RFC51 to power downstream application such as relational databases such as Postgres, MySQL, non-relational databases such as MongoDB or DynamoDB, or it can be your search stack or Elasticsearch. So basically, you have petabyte scale data lake on S3, and the benefit of having it on S3 is you save a lot of money on storage. Now what you can do is you can power your downstream search application to search your data, right, using incremental queries. This way you are only bringing operational data into your search stack, not the entire terabyte petabyte scale data, right? Only bring the data that you need. So let me show you a demo in this video. All right. So get ready, right? Again, this is a demo video, right? So I have my Elasticsearch, I have my Kibana running on my computer locally, as you can see. So if I show you, yeah, I'm using Elasticsearch 8.3.2. That's the, I guess the latest version, right? And this is my Kibana, right? Just before this, I just want to do a cat indices. I don't have any indices with the name Hudi, nor do I have any transactional data lake. So let's see this in action. So I'm gonna leverage a RFC51 change data capture to capture all the changes and basically power my downstream application. So I'm gonna create a Spark session, and then here I'm gonna define my Apache Hudi transactional data lake, right? So here I have enabled two settings, that is Hudi table CDC enabled as true, and I'm gonna get the before and the after part, okay? Now let me show you everything in action. So now I'm gonna insert two documents, record number 1 and record number 2, into my Apache Hudi transactional data lake. I'm performing on my computer, but again, this data lake could be on S3 as well. The only thing changes is the path. So I'm gonna execute the cell, and this could take about a minute or so. So we're gonna wait for this cell to complete. Again, all your streaming jobs are putting in data directly into your transactional data lake, and then using incremental queries, you can power your downstream application. This is the best way you could do it, really. So again, this is complete. Now we should see a HudiDB, and here you can see the metadata and my base file or Parquet file, right? The Hudi created. Now what I want to show you is this template. Again, this template is very generalized. Again, the code is there. You can follow along with me on my deep dive video, but I just want to show you the demo in this video. So I'm gonna run the template. So what it's gonna do, this template is gonna query Apache Hudi, right? And basically it's gonna figure out the begin time, and it's gonna perform incremental queries and bring record number 1 and 2 into my Elasticsearch. So let's see that in action, okay? So I'm gonna run this Python file. Again, the template is pretty generalized, okay? All right, I stands for insert. So I made 2 insert into my Apache Hudi transactional data lake, right? And the job is complete. Now let's see the Elasticsearch. So if I go to Kibana and if I hit my cat indices over here, look at that. We got a time-based indices now. All right. So now I'm gonna get this in data from here. I'm gonna show you. So I'm gonna do get. I think I have an extra space. Get rid of that. And then I'm gonna run, and let's see. Look at that, record number 1, insert, record number 2. Now what happens is the template will create a metadata file on S3. So now it knows from where it needs to start, right? So again, if I have to really fast show you without wasting any further time there. So if you see the last commit, the last process commit is stored on S3, right? So basically the metadata is stored on S3. Now if I run the template, it's gonna load the metadata from the S3, and it does not have anything to process because I've already processed my data, right? So if I run the template, and I just wanna show you this, okay? First, it's gonna fetch the metadata file from S3, and it's gonna perform an incremental query, and since it doesn't have any data, you will see that. So here you can see I don't have any data, so nothing is printed on the console. Now what we're about to do is basically I'm gonna insert record number 1, I'm gonna update that, and I'm essentially inserting a new record. So I'm inserting record 1 and 3. Before I inserted 1 and 2, now I'm updating record 1 and inserting 3. Execute the cell. So again, these are insert, update, deletes that are happening on your petabyte scale transactional data lake, right? So this can take up to about a second or two. And again, depending upon your use case, you can either go for copy on write or you can go for more, that is merge on read, right? So you can select the appropriate table version. Now this is complete. Now what I anticipate is when I again run this template, it's gonna fetch the metadata from S3 and it's gonna perform incremental queries, and it has to ingest that records, the new data, right? So if I run this, so the template will basically fetch the metadata from S3, and now it's gonna perform an incremental query, and it's gonna grab the update and the new insert. Okay, so as you can see, it did fetch the metadata, right? Again, table name, path, everything is stored in the metadata on S3, right? And there you go, look at that, you and I. So this is what we basically inserted, record number 3 and record number 1 was updated. All right, let's go to my Elasticsearch now. So if I do the search here, look at that, I have my insert, that's the new record that came in. Look at that, we are also updated that record, right? So again, it's a great way to power your downstream application. That way you're maintaining your petabyte scale data on S3 and you're saving a lot of money on storage, and you're only bringing the data that you need for your use cases, maybe 6 months, a year worth of data for your search application, right? You can run this job on a basically a daily basis, hourly basis, minute basis. You can just submit the job on EMR. You can use step function to orchestrate. I have videos on that as well. But again, I hope you have enjoyed the video. And if you want to learn more, please make sure to check the deep dive video on this. Again, the code and everything is given in the description, so make sure to check that out. If you have any more questions, let me know. I'll be very happy to assist you. With that being said, keep smiling, keep programming. I'll see you in the next video.